this? Where's your fucking that? You know what I mean? I'm saying, hey, you're quoting it, your claim, you back it up with
You're
substance.
asking someone with an airplane as their name and profile picture for the source on what
Oh,
aircraft.
Oh my
you
God,
got
it's
an
airplane.
airplane?
Whoa, I didn't see that. Hold on a second. Let me look again. Let me look real close. That is a legit airplane. Oh,
That's an airplane.
It's totally an airplane, man. You got
And it's like in the air. Oh, wow, dude. You getting the point?
Have you gotten the point that it's kind of common knowledge in aviation that the aluminum isn't used to construct aircraft?
Then why did you use it as one of your examples?
Because it's a different thickness and tensile strength holding back more
And what
pressure.
happens when you put your aluminum can inside of a freezer?
The liquid inside freezes and
Boom!
the can expands
and guess
outward.
what? There's liquid inside of the ISS. It would also freeze.
Why would it?
It's
insulated.
dude,
why would they?
You don't have to talk back
inside
and
a
say
freezer?
stuff like that, Shane. You can ignore them, Shane, and wait for someone to say something smart. It works better.
Nick, you realize that in
It's
space,
much better to
water
guide the
boils,
conversation
it doesn't
towards smart
freeze.
You
conversation
do
rather than
realize
entertain horseshit.
it's negative 455 degrees out there, right?
Water will boil at that.
And tell me why it's not boiling either.
Because it's
why are they
inside
allowed to
the
just hang
space
out
station.
there, just
Shit. It is not liking. It is not trying to stay connected tonight, is it, guys? Let's try Firefox. For those who endorse the celestial theodolite and wombats of the celestial theodolite, here is the real comparison. Yeah, when you compare the optical measurements to timing intervals made through geometric occlusions, there's going to be some differences, dude. Anyway. That's our premise.
Him, which is disingenuous to me because I never attempted to steal man
during that
That's
session.
a terrible defense. Ooh.
During that session, you will recall, I hope that it was not just myself who were quite evidentially convicting you of simply not possessing the requisite level of understanding of the topic. And we started to doubt your intelligence based on your failure to even comprehend that we were pointing that out and how we were taking what you were saying and producing that conclusion.
So what did I say, Stone? Enlighten me, please.
It was about the trigonometry itself and what you didn't understand about this little celestial theodolite, rather, during one of Alan and Shane's innumerable presentations. I can't believe how many times these guys have put this information out, and you guys still, some of you guys just don't get it. It's amazing. And I'm not going to go into specifics again, like I was even saying that night, that it's not my battle. It's one that I haven't taken anywhere sufficient time to study if I were to pick up the sword on it. But what was clear, we were talking about in terms of experimentation even, that when we look at the process, the method for the celestial theodolite, you were not really showing any coherent grasp on which were the independent variables, which were the dependent variables of the experiment. That's just for starters, Coffee. That was not the sole piece from which we picked the conclusion. This guy does not get it. He is not able to get it, or insert your qualifier here, not going to get it. Can't get it, won't get it, not sure why you're not getting it, but we have our guesses. And I expressed mine.
So what did I state was the IV, DV, and CV that you felt was wrong, and what is the correct?
Oh, he's getting all pro with the acronyms. At the time, it was about separating the IVs being the distance from and the time, you know what I mean, that kind of thing. Or actually, the height, I guess the peak height would be the IV. The DV would be the time, of course.
So you believe the height is the IV?
Well, yeah, you pick your peak.
So that makes the height the IV? You're 100% correct about that?
It's an IV, yes. So is distance from the peak.
Have you
that is an IV.
Have you spoken to the constructor of this experiment?
Have I talked to Mike?
Yeah, to confirm this.
Oh, I'm pretty sure I would have heard an objection to that by now. It's been a month or something, hasn't it?
Oh, because I spoke to him a while back, and he told me that was incorrect.
He did. And what did he say?
Yes, he said that there's no exact predictive model. There's no model exact to call this a model-based experiment, right? Which led me to the conclusion that it's just comparative, right? You can only compare what the two models produced, right? And then use that to predict the outcome.
So he said no, you just said there's no model, and then you pick from two models. Which is it?
He said there's no model.
No experimental model.
Exactly.
But then you're picking from two models at the end based on the DV that comes back?
Yeah, you must have just misheard.
So again, you're not making sense, Coffee.
You must have just misheard me. Clearly. What did I just say, Stone? Let me see if you heard me correctly.
Well, I was just saying, yeah, that's exactly what you just said. You said there's no experimental model. That's what Mike told you. Is that correct?
Yes.
And then you use the same word to describe the consequent in an analysis of it, where the DV where it comes back by the time you're gonna put that against one model or the other model. You said that too.
Yeah. So you clearly
Which is it?
So I'm gonna re-explain it so you can get it this time. Do it a little slow.
Yeah,
I
okay, what
got
did
you.
Mike say? What did Mike say?
So he said specifically that his experiment doesn't adhere to any experimental model, meaning it doesn't adhere to what we understand as the standard of an independent variable, a controlled variable, and etc. Right? And all it leads to is us comparing our two personal models, the globe and the flat Earth, and its outcomes, right? Because without a predictive standard, right, there's nothing to confirm which model is correct. But he's clarified himself that there's no predictive qualities, right? And it doesn't adhere to any experimental standard.
Okay, so see, now I understand why you were using the same word for two things. You're talking about the difference between an experimental model and a physical model. Okay, so when it comes down to whether or not this satisfies all of the criteria and the requisites to an experiment, an experimental model, maybe he and I disagree. Maybe he hasn't thought of it on these terms. And what the fuck does that matter?
Just clarifies my point.
What point? What the fuck does that matter?
That your critique, right, over me not understanding these model variables, these experimental variables, right? It's just bullshit.
No, it is because you see,
it's not held with any.
Is what you possessed last time we were talking. You see, that doesn't work. That's temporally illogical. Can you see that? That you can't assert that as any kind of like assessment. To say,
I hear you, Stone, but
I talked about now. I understand. No, man, that's what the fuck are you talking about, Coffee?
I hear you upset, buddy, but that's just another assumption
Hold
because
on,
I spoke to.
hold on. What exactly
Go
are
ahead,
we
Nick.
discussing here?
Dude,
Yeah, no, we could land it right after I say this. I don't want to take up the whole stage for this, right? It's not
Are
that
we just
important.
discussing how you guys are disagreeing on a certain
Variables,
topic?
IV and DV of cell Theo, I think.
Hey,
was the
Stone.
contention.
So IV DV's controls for cell Theo. Known elevation of the mountain peak. We can't change that. That's our control. You can change your distance to the peak. That's an independent variable that you can manipulate. That variable will also be will also lead to a dependent variable of the angle, because the combination of your distance to the control is going to dictate the dependent variable for the occlusion. Now you wait for the occlusion to happen in nature, so like you don't have any control over that other than your distance to the peak. Now we're comparing the outcome for two different models, the globe versus a flat Earth. If the Earth is a globe, the physical mountain will be lower in elevation. It's going to have a different time for the occlusion. It's going to correspond to a different angle. So you can look at it in terms of experiment, like however you want to break it down like that, or you can like endlessly discuss a philosophical disagreement or whatever. Like that's of no importance. What is of importance is that we get two different outcomes that's possible, and the measurement leans towards one model in particular that shows the correct predictions for what you would make for doing rise over run to the peak versus rise over run minus globe drop to the peak. So that's it.
Good call on the nomenclature right up front there, Alan. And if I recall correctly, you were actually the one to first mention the differentiation or the application of this nomenclature to begin with, IV and DV applying to the distance from the resultant angle, the peak, etc. And I would actually, sure, I would even agree the mountain is the control in that.
I'm so glad you agree because you came up with it.
Yeah, thanks, man.
I was like, yeah, you actually are the one that pointed that out the last time you and Coffee had this conversation that went nowhere. So that's like super dope that his takeaway from it was that there's somehow no mutual exclusivity and that we're comparing two models with no fucking metric. That sounds
that's his basis. Yeah, that's his basis. His misunderstanding is, well, you can just pick whatever model you want. And it's like, no, that's nothing to do with no. There was an actual observation that either agrees with my model and disagrees with the other, or agrees with the other model and disagrees with mine. That's what mutual exclusivity means. So it's a very real observation that supports either one or the other. It's not wishy-washy retro nonsense postage.
Yeah, but his takeaway is that like you can just choose whichever one, and it's fine.
Yeah, I know, but
that's the postulation of the null.
And his takeaway for some reason. He started with that and he ended with that. I don't understand.
Hey Stone, I got the numbers for you here on tensile strength.
Oh, God
Great,
damn
post
it,
'em.
bro.
I posted one. The spacecraft aluminum tensile strength.
Did you put that in the purple pill?
I can put it up there, yeah. The ultimate tensile strength, or UTS, is 42 KSI, which is kilopounds per square inch. So 42,000 pounds per square inch before it breaks.
Well, yeah. There you go. Nobody cares, I think, anyway, or whatever.
No, I don't think it's whatever. I'd like to see the doc. It's what I asked you to post, not just you type it out all pretty and I don't have a lot to go on here, man. Just your word. This is trust me, bro, kind of quality information level. I'm sure you can understand that.
So, do you have any rebuttal for the information, or?
Okay, that's
What
only
for that information is what he's asking.
That's only the quantification for T6, right?
Yeah, that's the aluminum that's mostly used on spacecraft.
Pounds per square inch. At what thickness? Nothing here. If you could post the doc, that might actually help. I don't know, man.
Tensile strength thickness doesn't equate into that. That's the strength of the material itself.
The strength.
Yeah,
You understand how you're only giving me
strength.
half a dimension?
That's how much force
Per what?
that material can withstand. Before it breaks.
So you've given me typed out spec for one type of aluminum and not the other ones we were talking about. So there's no quantitative comparison going here. And I asked for the doc. You can hear me, I hope?
Which document? Because there's thousands.
Preferably the one that you just read from would be super dope.
I don't know how this could be so hard. I don't get it. I'll be back in about 2-3 minutes. I'm gonna pour a bevy here.
Yo, I know you didn't just read from it and then say thousands and just not give the one that you just read from. That's wild, my dude.
Well, moving on from that super strong position put forth.
And no, that's what those measurement units are, Alan. MPa
Okay,
and
all right.
KSI.
Okay.
I just work here, but he was asking for the source of what you just read, and then you said what, like there's thousands of million, like, you know, but like wouldn't it just be easier to give him the one that he's just read from though? That's what he's asking. That's what he asked for. So
it's a long
there's
silence.
like engineering toolbox, stuff like that. But I posted one from the material data sheet.
nice. That sounds like a super good primary source. All right. Well, when Stone gets back, you guys can go over that, I guess.
Let's find what's new at Target this week. We've got a Tone Holiday 2025 edition.
Or we could do like something other than that. If anyone else wanted to talk about like anything, really.
Maps.
Coffee House Clubhouse. I heard Sacred's over there holding down the house. Did you guys adopt Sacred? Also, I heard there was a Clubhouse flat earther who disappeared after TFE and now came back as a Glowbird. Can you fill me in on that?
Yeah, you know, Sacred Family. Yeah, y'all already know. You feel me? I mean, y'all all family. Y'all know how it goes. You feel me? I mean, we go back and forth, but you feel me? I honestly love you guys. But yeah,
Well, if you
and
stole Sacred, you're gonna have some hate, but okay.
but and yeah, your boy OG, he's basically the founder of Flat Earth Gang. But yeah, he was gone for a little minute, about damn near 6 months, almost. And he recently came back, and yeah, he's technically a Glover now, technically, but yeah, stay tuned.
So there was a guy that didn't go to Antarctica, heard about the 24-hour sun, and then went back to the globe. Is that what you're saying?
Yeah, I say that lightly. Yeah, y'all, because I don't want to give up too much information, but I think y'all will get it when just try some heads on the back channel. I'll hit y'all up and let y'all know the details.
Could have just said yeah. Yep. That's what
Actually, I have an unconfirmed quote from OG Meatball that said he actually flipped back not because of TFE, but because of super good arguments that Coffee was making.
Man, I could see that happening.
Right, I would keep that text though for sure.
Oh man, don't gas me up, y'all. Do not gas me up.
No one could convince me that I'm opposite and back to the globe. There's no way.
Well, have you met flat earther formerly known as Jaren, who can hold the debate?
Have.
Who can hold the debate right now with stuff he said for one side of the argument against stuff that he's currently saying on the other.
I don't believe anything he says.
I knew a guy when Jeranism was still a flat earther called Jeranism Jism, and I don't know what that was about, but whatever.
I think you're asking for that sort of critique when you have that name. I think you probably expected that.
I mean, still funny as shit, but it's like, dude.
I don't know, man. I'm watching this soda can here get put in a vacuum, and it doesn't seem to be withstanding it.
Not surprised.
You're not buying it?
I'm not buying it, man. I put it up there in the Jumbotron. If anybody
And how many soda cans would it take for you to believe in it if I just gave you some for free?
Because it's 30 pounds per square inch versus 0.
It's
with
vacuum.
very low tensile strength. Aluminum cans aren't particularly high tensile strength compared
Dude, you're over
to
here
spacecraft
bragging
or
about
aircraft.
how freaking strong aluminum is, and suddenly I put it in a vacuum and it blows up.
Because aluminum
ain't good
in the can, it's a different kind of aluminum.
Well, I just looked up a 900 cubic meter aluminum container, and how thick would the walls need to be if I put it in a vacuum chamber with 14.7 psi inside and run the vacuum chamber to a 10 to the negative fifth torr? And it said that it needed approximately in a cylindrical shape, which the ISS has some flat walls, but I think it's basically cylindrical. It says that it's not technically cylindrical, but it said that it needed 10 millimeter thick walls to withstand that.
What strength of aluminum?
And if you went to spherical, you could get down to about 8 millimeters if you went spherical.
Okay, what tensile strength of aluminum? Do you have that?
Well, I can tell you the aluminum that it used was, because it gave a number. and I'm
I,
not
I've been,
sure. I'm not
I've
sure
been listening for
exactly.
a while.
Aluminum 6061-T6.
The
That's like
same
billet alloy,
stuff.
and it's not made of that. It's made of
Excuse-
2020 series.
Oh, it is?
Yeah, and it's like 3 to 4 mil thick the inner wall, and it's multiple construction. Like, and 3 to 4 mil aluminium, I suppose in American chat would be it's 1/4 inch or 1/8. It'd be 1/8, I suppose. So 1/8 for aluminium, and then sort of aeronautical grade aluminium, like 2000 grade. That could easily withstand a couple of thousand psi, guys. And like, we're only talking about 15 psi max.
Yeah. So, looking at it, the one I posted is, yeah. There's 3 kinds that are used. There's 2219 T851, ALLI 2195, and 6061 T6 is the one that I posted.
Yeah, and the T6 one, the 6061 T6, that's the one that it said if it's a sphere, if you make a sphere of that aluminum, that it could be as thin as 8 millimeters.
Okay.
But as soon as you get into cylindrical, it's like 10. And if you go with any flat walls whatsoever, you're getting up around 20 millimeters.
And how big of a cylinder?
900 cubic feet.
Didn't you say you're talking cubic meters, wasn't it?
Or cubic meters, excuse me.
Yeah.
Yeah, because the
So,
ISS is 916 cubic meters.
Is that its internal wall size, but or is that its external size? Like, we need to clarify that.
Well,
is that
I
inside or
asked for
outside?
volume, is what I asked for. The volume of the ISS is 916 cubic meters.
Yeah, that's
you
probably
can-
the gross volume. Let's go with that.
That's just the volume that I asked for. And when I asked ChatGPT if I had an aluminum container, 900 cubic meters, and I have 14.7 psi, which is what the ISS maintains, how thick would the walls need to be?
Yeah,
If
but
it's
that
in a
doesn't apply.
sphere,
The
doesn't apply.
habitable volume where people are in the International Space Station is about 388 cubic meters.
Super interesting.
And the ISS is sort of multiple sort of modules joined together,
Yeah,
so
it's
it's not a sort of
multi-module.
yeah, that's right.
It's
well,
not
the
one
farther
wall.
you get away from spherical, the thicker the walls need to be. The absolute thinnest walls you can have is 8 millimeters in a sphere-shaped container.
That's not
Now,
true.
I'm not going to
That's not
argue
true.
with you
out of-
about whether it's
No,
cylindrical
that's not true.
or whether it
Ken,
has flat walls. I'm telling you that once you go to cylindrical, you need 10 millimeters. And if you start having flat walls, then you need upwards of 20 millimeters.
Okay,
So you can argue any
Ken,
shape you want, but the
Ken.
thicknesses that they're quoting are thicker than the ISS.
Yeah, that's for no reinforcements. The ISS has reinforcement structures to support the aluminium paneling.
Okay.
Yeah, and there's also the internal walls. I just about said aluminium because this guy's English. Aluminum is the skin.
Hey, hold up. He's fucking Australian. Don't insult him like that.
Yeah, so I did give the benefit of the doubt because the vacuum chamber that I put it in was only 10 to the -5 torr, while the ISS is in 10 to the -7 torr. So those numbers are only going to go higher if I go back and change it to 10 to the negative 7. I understand you can have reinforced, you can use something on the inside to reinforce and make them a little bit thinner.
I mean, do you know how thick the walls of an airplane are?
An airplane is not in a 10 to the negative 7 torr vacuum.
It doesn't need to be, and that doesn't matter.
Dude, you keep on
because
trying to
there's-
compare apples to pineapples.
So I don't want to compare fucking water to air because they're different things. Just like I don't want to compare the air pressure at 35,000 feet to the air pressure at fucking 240 miles up. I'm giving it the benefit of the doubt by saying 10 to the negative 5 torr. And
this is
even in a sphere shape, the absolute best shape, where it's going to be its strongest, it needs to be 8 millimeters.
And this is something with a tensile strength of
6061 T6.
Yeah, so 290,000 pounds per square inch is the tensile strength of that material.
Okay.
That's how many pounds per square inch of stress it can handle before it breaks.
I'm just telling you, if it's in a sphere shape, in a 10 to the negative 5 torr vacuum, at 14.7 psi on the inside of the sphere, that it needs to be 8 millimeters thick in a sphere shape. You go to a cylinder, it needs to be 10, and if you go to any flat walls, it needs to be 20 millimeters thick. That's all I'm telling you. If you want to jump to another metal, that's fine. I'm just telling you what you need in a 10 to the negative 5 torr.
Okay, what's taken even then 74 in PSI? It's only 0, isn't it? Because the measurement of torr is in a billionth.
Also, I just realized, Brian, where did you get your numbers on the ISS?
As far as what?
The thickness.
I just grokked it.
Well, yeah, I did a similar thing, and I got 4 to 7 millimeters.
Well, I also got something like 4.8 millimeters, and that was in metric, and then I gave it the conversion to empirical, which gave it 0.01 to 0.019 inches.
Yes, 0.16 to 0.28, as opposed to an aluminum can, which is holding that much, like, more pressure with 0.100.
A can is like 2 thou thick, guys. Like, honestly, like the difference between them is massive.
All right, lads and ladettes, we're going to go ahead and wrap up for the evening. Sorry about the technical difficulties earlier. We will be, we will be back on Sunday with a live presentation on Globebusters from our very own Vambi from Aether Cosmology. Stay tuned for that on Sunday, 3 p.m. Eastern. And then on Monday, we're going to be doing Celestial Theodolite update number 26 or 27. Can't remember which one, but one of those two. And we're going to be going over some new spreadsheet stuff. I made a lot of changes to the spreadsheet, so we're going to be going over those. We'll be going over some data analysis of said spreadsheet. All right. We'll be doing that on Monday. And then Tuesday, of course, Shane may or may not have a presentation ready on how they've confirmed the distance to astronomical objects. So all the celestial bodies, they say, the sun's 93 million miles. Well, how do you know that for sure? Well, we sent a radio signal. Oh, really? Well, Shane's going to tell us all about the radio wave experiments that they did to confirm the distances. So we'll see how that goes. That'll be on Tuesday, 8 p.m. Eastern.